Sean and I discussed some things that you may not have heard before and may not have read anything about before. And in particular, Sean brings up the importance of the ground rod and its connection to the earth and its resistance to the earth. But by way of explanation about the time frame, um, we originally recorded the video about 4 weeks ago, and I spent the next 2 to 3 weeks trying to edit it and to get it to look right, and it never did. Uh, the audio didn't line up, the video quality wasn't good, and no matter how I tried to maneuver it, massage it, it just didn't look good. So Sean and I talk on the long path almost every day, and I asked him if I could do the interview again, and it's his year end with his business, but he agreed to do it. So we recorded the discussion again. That took about 2 hours. I've edited it down to about 35 minutes. And this time it looked pretty good. I had it all done except for the introduction. The hard drive failed in the computer because the power supply went nuts. So I had to get a new power supply and format the hard drive because it was just beyond recovery. And with that, I completely lost the edited video. So I had to start all over again. Fortunately, I had saved the original interview um, off of WebEx and a separate video of me with another camera and the audio yet on a separate track. So I have those three things that I could put together. So I've re-edited the video. Again, I put a lot of effort into it because it has some really important information. So here we go. After a lot of delays, it's Sean Billy Williams, really nice guy, ZS1 SBW, and we talk about grounding, bonding, earthing, RF grounding. Didn't really touch on lightning arresting because it's a whole separate can of worms. So here we go. ZS1 SBW.
Yeah, you too. Whiskey 6 Lima Golf ZS1 SPW. Hello, Jim.
Hello, Sean. Um, I've been wanting to talk to you about the confusing issue for me for 58 years, and that's bonding, grounding, earthing, lightning arresting, and I don't know if there's another one. RF grounding, I guess. Did I mention that? So there's all of these things. You've done something that several things that I don't know of anybody else who's done that. So let's start with uh, your system for grounding your station without worrying about it being AC or RF. Tell me how you grounded everything because it really is different from everything I've seen.
Um, okay, so thank you, Jim. Always a pleasure talking to you on the long path, and then also on this
Yeah.
optical fiber path is great as well, undersea cable path. Um, so most amateur radio operators don't have the advantage of very high towers away from the station. Most of us have our towers close to the station with compromised height. Even I do. I don't have an ideal height, 65 foot. Um, and some operators are they have end-fed half waves as we Tesla coils as we spoke about, and or balance antennas. So there is a certain amount of RF that's induced into the station because of the proximity of the antenna. Um, and the most important thing for me is the earth rod, the ground rod resistance. And the reason why I believe that's important is because um, the entire earthing path um, is connected to your house or my house and to our neighbor's house. Um, and if, for instance, if there isn't a ground rod, in some cases there isn't a good ground rod or a good ground resistance, and that's defined as 5 ohms for sensitive equipment radio stations. for the NEC or for the South African code or the British code. It's just less than 25 ohms, as long as it's below 25 ohms. And for what we're doing, it's not good enough. So just
Can
as
can
yeah,
I just stop you there and kind of restate in a different way what you said? That no matter what code you look at, be it British or South African or the U.S. codes, and there's several in the U.S., they really are all kind of about the same. That the electrical system has to have a connection to the ground of 25 ohms or less, and in most cases, probably it's there. Now that 25 ohms is um, not, you said ground rod resistance, and you don't mean that it's the resistance in the ground rod. You mean it's that coupling between that rod and dirt over a certain distance measured in a specific way, or
yes,
with a specific device.
yes.
And let's see, what was the other thing you said? And let me also say that as a former building inspector, for all of the times I inspected a house, which was thousands, I never measured that resistance. So again, ground rod resistance is the resistance to the dirt, let's say. Is that fair? So
Yes,
let's call it, maybe that's sort of earthing. And
yeah,
then and that connects to the main panel.
yes.
In your case, you'd call it a console.
Yeah, we call it the council panel, or the council supply board, or the council earth, and in your case, it'll be the main your main
The main
supply
panel.
panel. The
Yeah.
different terms, but the same thing.
Same thing.
So
Yeah,
it,
same.
yeah.
The box may look a little bit different because of the way we connect, but it's basically the same. And the idea, the other thing that I want you to talk about briefly is uh, what is that designed for? Is that designed for radio stations or for something else in the code when at that 25 ohm resistance they're
So,
talking about?
so the code doesn't take what we do into consideration. It's for appliances, stoves, hot water cylinders, washing machines, dishwashers, and all the basic household appliances. And for that, it's good enough. And the reason why it's good enough, because all houses will have a residual earth leakage device, 20, and it will have a sensitivity less than 40 milliamps in most cases. And any of those devices will trip the residual leakage device. So the safety of the circuit for those types of devices and appliances is good enough. The earth path is not a fault path. The fault path is to neutral, because the earth would bond in the council panel in the council supply board meter board. It would bond to the neutral, and
Yeah.
so and it's essential, because you're not going to find it. You're not going to be able to trip a breaker
Yeah.
to earth with a 25 ohm earth ground rod resistance.
So
And
what
so
you're saying is if we opened the cover and removed the interior cover on the console or the main panel, that we would find a ground bar and a neutral bar, and they're tied together at that
yes,
point.
yeah,
And they're tied; those two tied together, and they go down to a common point in the U.S. a common point box, and then from that box it goes to the ground rod. And in
yes.
that common point box, the TV, gas line, water lines, they're all ground, they all come together as one ground. Also, as far as leakage goes, those still aren't in common use here, uh, where it would trip at 45 milliamps or some. And that's a contribution that came from what country?
Yeah, that's a South African invention, and it's been a standard in South Africa for many years. And it saved a lot of lives. It's a good device to have. It can be annoying, and there are instances where you wouldn't use it. So, for instance, if you didn't want to, an earth leakage on your station, you could put an isolator close to your operating position, and you could bring in a circuit that's not on a residual earth leakage with an isolator within a meter and a half of your working position, and that would be legal, and you could do that. So there's a lot of ways to do it if you wanted to. But going back to your previous question about appliances, so for appliances and for household devices, the code's good. But for what we're doing, it doesn't make provision for what we're doing. And so there's this gray area, and this is the reason why nobody has a clear, kind of path to putting in the right earth installation for a station. We all do it in different ways, and so obviously we want to compress this into the shortest possible time, Jim, so we can get the essential detail. So for someone like myself starting with my station, the first thing I would do is check the ground rod resistance. Now in South Africa, it's a legal requirement to have the ground rod resistance measured and certified by a wireman. So someone who has their wireman's license, that it's below 25 ohms. And you would have a certificate of competency, which if you purchase a house, you will have that with the purchase of the house, and then you would check it. So, but I wouldn't take that for granted, because earth rods change, ground rods change over time. Some are copper plated, and the copper evaporates, and you end up with a steel rod. I sent you some photos of some rods where the copper had evaporated within half a year.
I'll put one of those up on the screen now. Yeah.
I won't use a copper plated steel rod. I use copper water piping, class 2 water piping, for my earthing system. So I would, the first thing is to determine what that resistance is. And if the resistance is, let's say you're fortunate and you check it and you actually have a very low ground rod resistance, let's say you have 5 ohms, which is the top, I would say the top limit for a radio station.
Yeah, let's restate that again, because as I said, it's never discussed, and it's probably the most important thing that anybody's going to hear in this conversation. And that is, it starts at that ground rod. And if you don't have that right, a lot of other stuff doesn't matter. If you're just thinking about safety, period, it's a good idea. And we don't certify any of that stuff. So you're saying it starts for any amateur building a station, start with a ground rod, get a good connection to ground. Yeah. A driven copper pipe is a good way to do it. There's lots of ways to drive it.
So the first step would be check what the ground rod resistance is, and then you would have to come up with a solution to bring it down to 5 ohms. And let me tell you why I believe that's important.
Okay.
So let's say so your station is connected, and I like the way that you do it with a copper pipe at the back of your desk, your operating position, and you bond everything onto this pipe, and then you take it to the common earth, let's say the earth which runs with the circuit back to the main panel to the console box. So okay, and if you take that approach, the reality is, though, your whole station is connected to the entire wiring system of your house. Okay, and if you are a newbie and you start out with an end-fed half wave, the other side of the circuit, which is the earth conductors that run with a twin and earth, we call it twin and earth, which right. is the same type of wiring that they use for plug sockets and outlets, runs through the entire house, and you have a nice radial system, yeah. which also doesn't stop at your console, at the console box. It goes back onto the earthing system that goes to your neighbor. If your neighbor has a nice ground rod resistance, then his ground rod is going to be the ground rod for your station. So so from an insulation perspective, the first thing you want to do is make sure that your ground rod resistance is the best one in the neighborhood, and that none of your RF ends up on the earth that runs between, or even on the neutral, because it can also end up on the neutral, because the neutral's floating if your earth isn't bonded properly. If your earth isn't where it ties to the earth, where your neutral ties to the earth at the bonding point in the council box, or the meter box, then the neutral becomes a reflector, a radiating a radial in your antenna system, depending on how you've got your station set up. So all of these conductors become part of the RF circuit, and that's the reason why that ground rod is where we should start,
Yeah.
and make
So
sure that
there is more than one reason. There's several reasons why that connection, which, as I said before, is almost never discussed, is missed by so many, and the consequences of that are all kinds of problems, and we can get into some of
RF
those.
neighbor's house and
Neighbor's house, maybe RF on your microphone. In this subdivision that I live in, they wired intercoms in each of the rooms, and there's one at the front door, there's one at the back door, and guess what those are? They're audio amplifiers with wires connected. Those wires are not even a twisted pair, because I've gotten into the wall. It's just an antenna. So, if I don't have things right, I could be getting into my neighbor's intercom, even with it off. But anyway, so
so
that you make a really, really important point. That's
yeah,
yep.
and so there are exceptions to this, of course. We have, if you have a station, let's say you have installation like Mikey K6MYC, a good friend of ours. His tower is almost 100 foot. His hardline runs for about 800 foot
Yeah,
away.
isn't it? It's a long way.
And
Yeah.
it's a balanced antenna, and his linear and his transceiver are coupled together with a feed line. He doesn't pay too much attention to his earthing system, because he earths to his socket outlet earth, which goes back to the
Well,
main, to the council earth. But his balance antenna and his system is set up in such a way, and it's so far away from his station, it has a completely different, and we
and
can't all have that.
and his feed line is buried, so it virtually is earthed, because it's
Yeah,
coupled to whether he likes it or not. He's got 800 feet of ground rod.
yeah, and he's got no neighbors. His neighbors are,
No.
you know,
Well,
are miles away from him, and he's
been there, done that. Yeah, I know what
yeah.
that's like. Yeah.
But my neighbor's right next to me, and so they're all around. And so if I'm sharing their ground rod and their earthing system in their house, and it's coupled to my station, it's going to cause problems. So in my station, and going back to, I have 150 millimeter squared conductor, which is what I call my RF earth, my main RF earth. Everything bonds to that point. So I run individual earthing conductors to that point, from the linear, from the transceiver, and as home runs, as individual runs. So you can do it like you do it, with a pipe at the back or a copper bus bar, and you bond onto the bus bar, the copper pipe, and then that connects to a point. Mine connects to 150 millimeter squared, and that's a number 7 AWG7 conductor, which is 10 millimeters squared by 15 conductors. And the reason for that, again, is because of the skin effect. You want to make sure that you've got a lot of surface area. You don't want one big thick conductor. You want a lot of surface area. And this goes outside my station to an auxiliary electrode in the ground.
Yeah.
That
And could you describe that? Because I don't know of anybody else. There probably is, but I don't know of anybody else who did what you did. So tell us about that, because it's different for sure.
So I have a earth rod resistance of 3 ohms, 3.1 ohms. Sometimes it's 2.9 ohms, depending on the weather. When it in winter, the resistance drops a little bit, but in summer it's around about 3 ohms or just a little bit, 3.1 ohms, somewhere there. That's the ground rod resistance that I have. So my station couples to an auxiliary um, earth electrode system about 1.5 meters outside my station. So as it goes through the wall, I have a core hole. I drilled a core drilled through the wall, and then I have that 150 millimeter squared conductor coupling to an earth rod. And then that earth rod is bonded with earth rods back to the council earth. So all bonded together. And
Right.
then from that earthing point, that I run conductors, 10 millimeter squared or AWG 7 conductors around the property and terminate them at the ends with 6 meter earth rods, earth conductors at every end of those. And by doing that, I was able to get a broad distribution of earthing points into the ground, because we're on a sand dune here, and coupled to the earth to get the earth resistance down to the 3 ohms. It's not easy to get 3 ohms, so you have to
Oh,
invest.
it sounds like a hell of a lot of work. So
Yeah, you have to
so
invest.
you
Yeah,
have buried wires in the ground,
in
and
the
they go
ground.
and they terminate with another driven rod.
Yes, another driven
Okay,
rod.
so now do they fan out from a common point?
From this earth electrode that's outside of my station, which I call my RF earth. It's an
Okay.
auxiliary electrode, um, but I call it an RF earth, which is the main RF earth for the station, and they fan out from there. Uh, I use conductors, AWG 7 conductors which are coated like normal house wire, so they're not it's not bare copper, and they run under the ground and they terminate at random points around the property, so that I can get a broad distribution
Yeah,
of.
that's interesting. So you intentionally picked different oddball lengths
Yeah,
because you didn't want something that was resonant, like
absolutely.
um, yeah, you wouldn't want them all to be, let's say, 20 meters long
No,
or
you would
2 meters long.
you wouldn't want to, and as you would know, if this earth conductor, which goes to this RF earth that's in the ground, was a quarter wavelength, I would have some problems as well. So that's also something you need to take into consideration. You don't really want this conductor you don't want it to be a quarter. Look, it would, then it already would probably be too long, and that's why I've chosen the bottom floor, so as close to ground as possible. And I'm using class 2 water pipe for these earth electrodes, because you can wash them down with water with a hose pipe. That's what I do. I wash them down into the ground where
Okay,
I
but
am. I do that.
when when you say wash them down, basically you're taking like a garden hose and connecting it to the pipe. Then you're using the water pressure to kind of auger your way into
Yeah,
the soil,
yeah,
and because you're on a sand dune, it's
yeah,
in some
it's easy.
places you may not be able to do that,
Yeah,
but you might be able to get in the ground 3 or 4 feet, even in a tough place,
yeah.
or go on an angle, or maybe some other direction. So um, now, so you've got a lot of copper in the ground then.
I have a lot of copper, and I started with it, and I've added over time. And when I got to my 3 ohms, that was where I stopped with it. And
Oh,
I've
yeah. Was it a straight line in terms of resistance, or was it were the incremental changes always about the same, or did you really have to work at it to get it down to the 3 ohms? Uh,
when I started, I got to about 7 ohms, and then to get to that 3 ohms, it took a lot more effort. That was with the radial system, with earthing at the end of the radial system to bring it down. But we are between 3 oceans, so the Indian, Atlantic, and Southern. We're essentially floating here, as the water table is 1.5 meters down. We spoke about this before. So I am fortunate that I've got very good
So
wet ground.
your water table is down about 4.5, 5 feet, and
Yeah.
oh yeah, I was going to ask you, how did you measure? How did you know that was 3.5 ohms?
Well, this is I mean, I have one of these in my station, part of the station equipment that I have it, and there's different. This is a Uni T, and it's you clip it around the ground rod, and it gives you the resistance of the rod.
Do you,
So it's a
do you drive another rod into the ground somewhere, or do you just clamp that
no,
on?
you connect the rod to your electrical system, and you couple it around the conductor that goes to the rod, and it calculates. It uses high frequency pulses, and it calculates the
Okay.
um,
And
yeah.
I would think that, and I haven't checked, but I would guess that those devices are available for rental uh, from a rental yard because it's a fairly expensive device. And for a lot of guys, it's the price of a transceiver. So if you got the choice between that thing and a transceiver, you're going to buy the transceiver. But you could perhaps rent one of those, or if you've got, you call them a wireman, we call them an electrician. You may have a friend, or you may be able to call an electrician who comes out, parks his truck out in front, goes over, measures it, because you really should have one. A decent electrician
all,
would measure it
all
for you, and you're done.
all electricians would have one. A wireman's license is an electrician who's licensed to certify installations. So that's like a master electrician. They all have these devices. It's a
They
standard
must.
device because the old method is you can't use it in buildings with concrete slabs, and this is a very suitable device for any building. You don't need to put in auxiliary electrodes around the
Yeah, it would
property.
drive. You drive a couple of rods a certain distance
The
apart.
old
Yeah,
yeah.
and put voltage between them and read the resistance, the current flow, and the resistance. Go ahead.
So to make it easy for someone who's putting a station together, and going back to your thinking where you use the earth that runs with the supply, the AC supply that supplies your station. um, if they do the work on the ground rod at the meter box, or the main supply panel, and they improve that rod by driving some other rods, and bonding them together, they can also achieve the same result. But it all starts with knowing what that
Yep.
resistance, that ground rod resistance is, and some guys probably won't even have
No, and you know what? You're right. And what in I've seen it several times where the gas company, natural gas, comes out, takes a measurement where they're connecting natural gas, and drive another rod because they're not happy with the resistance, in particular of the OOFR ground, which is a whole other issue.
and that's also in the NEC, and so not just the NEC, but this is what's called an auxiliary electrode, and there's a few ways around the code, that you can get around the code for auxiliary electrodes. One of them is there's a provision. It's a 25054. I don't know if you know this. It's an auxiliary electrode. It's really a silly regulation, but exists. So, for example, if you have a lamp pole, they put a little electrode down. The electrode's
They do.
meaningless because it's not bonded back to the other. It's not bonded to other earthing electrodes in the circuit. It's just sitting on the pole. And let's say if it's 25 ohms or above 25 ohms, it's not going to draw enough current. And if there's a fault, it'll just bleed into this electrode, and then you'll have some potential around the electrode, and it's potentially a hazard, but it's something that's in the NEC which has never really been cleaned up. And when you work with earthing electrodes, it's really critical that you bond them. You should never put an auxiliary electrode down and not bond that electrode back to the meter panel
Yeah.
electrode or the console electrode. And when you do this, you need to take into consideration the length of the electrodes and the distance between them. It's actually the length of the electrode times 2 to the next.
Yeah.
That's the actual ratio.
And let's
So that
talk. Let's talk about why, because it's obvious, but you didn't say it. you could have a difference in potential voltage
Yes.
between those two, and that could be a hazard that could kill somebody or
If you've
start a
got So if you've got, let's say, if you don't have a path to neutral on your station, and the Earth goes hot, it's going to end up at that electrode, that auxiliary electrode. It's not going to trip a breaker because it's 4 amps
no,
or something,
if
110
it's not
volts.
on the neutral. Yep.
And if it's 220, it'll be
Yeah.
9 amps. It's still not going to
And,
trip the breaker, something around
and
there.
for those who think that can't happen,
Yeah.
the house I bought, there was open ground, open neutral, reverse polarity. And as a building inspector, I inspected buildings, houses in particular, that burned to the ground or had a fire in a room because of something like that. So th- this is not just for the fun of it. This is crucial safety information. Make sure that you have a decent ground, period, it's whether or not it's for RF, but you just want to make sure that you've got, and that 5 ohms is a good target, is a
Yeah.
good target to be at.
And so the the fault is via the neutral. The fault will always flow via the neutral. If the Earth isn't bonded to the neutral, so if you have auxiliary electrode and
Right.
that isn't bonded back to the meter board or the console Earth electrode, which is bonded to the neutral, you're going to have a hot electrode in the ground, and it's going to be at the potential of the supply voltage, and it's going to also have potential in a perimeter around it. So a child could end up getting
Yeah,
electrocuted. Somebody who, if
we didn't exactly say it, but um, in the past, I've talked about it being a three-wire system. That's true inside some places, but really it's 4 wires. It is each side of neutral. So you got two hots, neutral, and a ground. Now, if you have elevated poles, electrical poles, you you'll see a carrier and two cables wrapped around it. The carrier is the neutral and each side of neutral. But that's not the whole system. The other part of it is what you've said over and over and over again. Again, it's the ground, and those are all crucial parts of the system. 25 ohms to me, when you think about uh, what that would be with a substantial amount of current, just seems crazy high. I don't know why
it,
it's
it,
so high.
it isn't a practical value. But if you have a residual earth leakage on your socket outlets, for all socket outlets in your house, it's fine, because any leakage, between, it depends on the device, if it's 25 milliamps or not more than 40 milliamps, but the residual leakage device would always trip for an earth fault. So it's 50 hertz or 60 hertz at supply voltage. So
Well, I'd like to finish with a brief discussion. And I'll try to show some pictures laid over this later. But basically, at your radio station, which is different from a toaster or a water heater or any other thing, you want to have each box in your system that does something like a transceiver, a linear amplifier, an antenna tuner at the same potential above ground, or at
absolutely.
either ground or a little bit above. So it's best to run each one to I use a pipe we talked about earlier, but each one, instead of daisy chain, if you daisy chain them, this one may be 10 ohms, this one may be
Yeah,
8, this may be 6, this may be 4. Instead, run them all to that ground rod pipe. I don't want to call it a ground rod pipe, and then that goes to your grounding system. And
yes.
before we started, I mentioned to Sean that I wasn't a big believer in RF grounds, but I'm getting religion as we do this. um, if you doubt that it's important, and have, even if you're on the second floor, tie them to something and do the best you can. But if you take the cover off one of my amplifiers and you key it, stuff in this room goes nuts. because
Yeah.
I've done that where I'm adjusting something because RF is just going all over the place. Now, I did, and I'll try to show some pictures of this now. I did put up panels that have foil insulation. There's a copper strap that's separated from the foil, but it runs on top around the room. And I tied it all together, trying to keep RF in here. And to the point, and to the point, it works pretty well. I've got a clock on the wall that automatically checks. I guess it's with WWV or one of those things to update the time. It's still off by an hour because it can't hear it because I've made the room pretty much RF type. And I was
Great.
concerned about neighbors and interference. Did you, as we're running out of time, Sean, was there anything else that you wanted to cover that is crucial to your description of your station and the safety and the RF ground and the rest of it?
So just to reinforce the point you made, I don't believe the feed lines between the transceiver and the linear are good enough for maintaining, let's say, the lowest ground potential between whatever devices you have in your station. You must have a good bonded earth to a bus bar or to a copper pipe or to an RF earth, and never daisy chain run home runs. So each individual, and if you can get those copper plates that go under the transceivers or under the linear that some of the outlets supply, those are fantastic. I think that's one of the best things.
Yeah.
If you can them and use them.
You see those in contest stations, and that's an RF, we'll call it an RF rich environment, to say the least, because you might have 5 operators going this at the same time, each transmitter running 1,000, 1,500 watts, and if that guy keys down on 40 meters, you don't want 20 meters going nuts because 7 megahertz times 2. And then the guy who's on 10 meters, the guy on 15 maybe is lucky. So they have to do extensive work to to keep it as clean as they can from box to box to box.
Him as well,
Yeah.
yeah.
And I like braid because of its surface area um, being fairly large, and I want as low an impedance path back to that pipe. And I did use a 3/4 inch pipe because I wanted a large one, and I'll show a couple of pictures of that. And I just clamped each one with a ground clamp, like you'd see on a ground rod. That same clamp goes around the pipe.
Yeah, that's a great setup. And it can be done quite. And again, there's leeway for innovation and thought and custom. However the operator feels, the amateur radio operator wants, feels they can add value or use whatever materials they've got. But there's some good principles, and those are them.
All
Thank
right.
you.
Yeah, thank you. So let's end it here. And it's been a long discussion, and I really appreciate your time. ZS1 SBW, W6LG, over.
Yeah, Whiskey 6 Lima Golf ZS1 SBW. I'll see you on the long path, Jim.
Yeah, that's right. Long path rules. All right, thanks. Hi, I'm Jim W6LG, your ham radio Elmer here on YouTube. Welcome to my radio room in Rockland, California. I want to do a few more things with the AA35 Zoom that works incredibly well. I'm really happy with it. I've just turned it on. It's immediately connecting itself to the software. What I want to try to do is roughly measure the length of two pieces of coax. Actually, we could do three if I want, and then also look at the loss with that coax and see how that compares with the data sheets. So I've got LMR 400, RG8X, and let's do at least two of those. And I'm going to switch over to the screen where I can bring up what it shows on the Rig Expert screen. So I'm going to go to that now. So right now I've turned on the Rig Expert, and I've got all parameters up on the screen. So let's connect up. I've got some RG8X. I think it's a little bit less than 100 feet. Okay, I've shorted the end of the coax, and let's look at the instructions for the zoom here, and I'll bring that up on the screen. Just a quick comment about the instructions. They're very well written. They've got headings, subheadings, capital letters where they belong. There's a couple of mistakes in English, but it is so much better than most other instructions for amateur radio equipment. And it talks about velocity factor, and if we know the velocity factor, we can do a quick test and come up with the length of it. So what it says is the speed in a vacuum is 983 million feet per second. All right, so if we take that number and we multiply it by the velocity factor, we get another number. And if we take that number and we divide it by the lowest frequency, we divide it by the lowest resonant frequency, and then we take that number and divide it by, or multiply by a quarter, or divide it by a quarter, however you want to figure it out. Okay, so before we get too upset with that math, I've done some of it already. So like RG58, the velocity factor is 66 times 983 million equals 649 million divided by. Now we got to come up with that lowest resonant frequency. So let's do RG8X. I believe the velocity factor is 78. I'm going to bring up a calculator, and let's see if we can make this work. So we've got 767 million. Now we've got to find the lowest resonant frequency. So I'm going to connect it to the Zoom, my buddy the Zoom. And I'm going to change, I've got a short on one end and the other end that is flapping around. Put that on. All right, and then I'm going to bring up that screen again. All right, now I'm going to go to RX chart, and then I'm going to input a frequency. So I'm just going to go down to 0 to, so I'm going to go to 2 megahertz, and let's put, I'll show you that. So I've got 2 megahertz. All right, I'm pressing OK. Back to RX chart. And I'm going to tell it OK to do it. So I'm hitting the checkbox. Okay, the lowest frequency the lowest resonant frequency, is 1.963 megahertz, or 1963000. So now that we know that, let's go back to the formula. Okay, so that number was 1963. So we're using RG8X. So 767, 185, 384 divided by 1963 and then three more zeros. So 1963123 equals, and we're going to take that number and divide it by 4. So divide by 4 equals, that's the length of the coax. And I believe that to be relatively close. So it's about 98 feet. All right, now we know that. What else can we find out? All right, so I'm back on all parameters, and I'm going to ask it to show me that. Oh, I've got to change the frequency. All right, I'm going to change the frequency to 30 megahertz. Say okay, okay, okay. All right, so let's bring that up on the screen. Again, I've gone to 30 megahertz, which shows up here. All right, the return loss is 3.65 dB. Now that's sending a signal out and coming back. So half of that would be about 1.8 dB. We're at about 100 feet long. Okay, there's the table, 30 megahertz, RG8X, 2 dB loss. I measured 1.8. It's a little bit short, but it means the coax is good. Okay, I've asked the AA35 to do its thing again, and let's bring that up on the screen. And now it measures 1.4, so it would be half that much, so 0.7. Let's go back to the table, and that shows 0.7 also. All right, so there are two more functions you can do with the AA35. In some of the more expensive models, it doesn't automatically do. You just ask it to do it, and it has you do a couple of things, and there it is. I opted for the least expensive one because it was the least expensive one. I haven't regretted it. I may have wanted one that went a little bit higher in frequency, and to that end, I'm borrowing a faster, not faster, an AA 3000 that goes to 3 gigahertz. I want to play with a bunch of things, and we'll talk about that later. If you have any questions, or if you have another way of doing something that I did, or maybe you're not happy with the way I did it, which is okay, let me know. Post it below. If you have not subscribed, please do that. I'm Jim, W6LG, your YouTube Elmer. Thank you very much for watching 73.
switched on my radio, I heard nothing but noise.
Hi, I'm Jim, W6LG, your ham radio Elmer. Welcome to my radio room here in Rockland, California. In the past, I've used a nano VNA a lot, and the problem I ran into was the thing would fall apart over time. And let me show you what I'm talking about. This is a standard nano VNA, and it has two SMA connectors. They're mounted on a circuit board with a couple of prongs. The problem I ran into was that over time the SMA connector would break off. My elegant solution for that was to put the thing in a metal box and run jumpers over to a B and C connector. Yeah, I know. It doesn't look very good, does it? And it's probably pretty awful as you get higher in frequency. So what I got was a new nano VNA, and this is version 2. I made contact with the manufacturer, and I want to say this now so I don't forget. Starting August 15th, tomorrow, at the time of recording this video, they're going to offer 25% off with a coupon through this video. So, and I'm not being reimbursed. I don't have an affiliate thing with Amazon, but I'll have the Amazon link and the coupon link in the description. So if you decide to order one, it's 25% off. We'll look at this nano VNA. It's got a funny title, like Nano VNA SAA V2. I don't understand that. What I do understand is it's pretty well built. Now we're going to test this out right after this.
This is my song about the hobby of ham. I've taken up your time with my freaky jam. If you hear my CQ, you can give me a call if you choose. We can talk about the weather or the bottom of the cycle blues.
Okay, so this is my new nano VNA with its built-in SMA connectors that are mounted to a metal band that runs around the perimeter and ends up over here. So these connectors appear to be, and I'm trying to wiggle them and they're not going anywhere, nicely installed. And so the failure that I had with the other VNAs is not going to occur with this one. So what I plan to do is run the calibration program. I'm going to use this jumper and calibrate using the devices they provided here. And then I'm going to string, again, a bunch of coax connectors together. And what I did is I got bins of used coax connectors. Some of them are 40, 50 years old. And let's see how much loss there is in 10, 20, 30, 40 of these. We put them all together. I've got an accurate device to do the measurement, and I can short out the far end. All right, I've got the Nano VNA version 2 connected. And again, there's a coupon offered by the company that manufactures these things, and I've got a link in the description, and I've got the Amazon link. And again, I have no affiliate link with Amazon. So what I'm going to do is connect this to my computer, because I think that's the easiest way to show what's going on. If I try to do that on the screen, it's got a lot of reflections and things. So I've decided to do this with one of the PC programs that I have, and so I'll connect it to this device and start stringing connectors together. Let's see what happens. Okay, now here comes the fun. And I don't even know where to start. Yeah, I do. Let's start with a female SMA.
And go to, okay, where do I put it? Okay, there. Go to something else. So we've got a female SMA. I've got a double female SMA. Okay, here's a female SMA. And let's put that in it to a UHF female. Let's go to a double UHF male. let's go to BNC next. So let's grab. Okay, found one. Here's UHF mail BNC.
Different bands. I'll have to recalibrate I'm going to recalibrate the NOV. I want to get as good a result as I can. Again, if you're interested in one of these guys, and so far it's been pretty good for me, I'll have a link on Amazon and that coupon from the manufacturer, which is 25% off beginning the 15th. And I'm filming this, do you call it digiting? I'm filming this August 14th, 2021. And we'll go from there. We'll see what happens. All right, there'll be a break in the video as I clear the table and make room for even more connectors. So stand by.
Okay, one of the coax connectors that I suspect is trouble is in the circuit. Yeah, it sure is. Okay, let me get that one. Let me get that one out. What do you think? Think it's bad? Okay, I rechecked some of the coax connectors and retightened them. There we go. So now we're back to quarter dB loss. Well, that's an interesting thing then. A slightly loose coax connector at 10 meters caused a bunch of loss. All right, let's add in the whatever I can, and we'll be at about 60 connectors. And yeah, we're about 4 feet in length. That's a little off, but my velocity factor is just a wild guess. So anyway, now that I got, I'm going to add in a few more connectors, and then we're going to go up in frequency. So having them tight, look at that, compared to what it was. Basically, within the margin of error, half a dB return loss, so 0.25 dB going out. All right, one more stab at the rest of the connectors, and I'll try to make sure they're tight this time. All right, so at 2 meters, we are at about 1 dB loss, which is a lot less than I would have thought. All right, a lot less loss than I would have thought. And there you go, over 60 connectors, more than 4 feet in length, and not enough loss to worry about. 7.3 from Jim, W6LG. And again,